If you're here, you're probably intrigued by food 3D printing, so we have something in common. You may be wondering, who is she? Why should she tell me about food 3D printing? Well, that's me. Hi, I'm Gaia, eating food since 1991, printing food since 2016. I have designed and built a food 3D printer myself. Yeah, I will tell about that later. I have a master's degree in chemical and food processing engineering. The diploma is upside down because even engineers make mistakes. Because of my studies, I was introduced to the world of food 3D printing, and I had the chance to work for the Cook.3D project and to be a speaker at the 3D Food Printing Conference 2020. Check the video if you're interested, link is in the description box. I work at HRW FabLab, a big place filled with digital machines in Bottrop, Germany. You now may ask me, what are those things? What is a FabLab? What is a digital machine? Well, FabLab stands for Fabrication Laboratory, and it's a place where personalized objects can be created by digital machines. The idea was first introduced by this man, Neil. Digital machines are machines controlled by a computer, and there are a lot of types. For example, 3D printers, CNC milling machines, laser cutters, and so on. But going back to the digital part, it basically means that instead of being manually operated, a computer tells the machine what to do and how to do it. So, for example, instead of being poured in the mold, the pudding is printed. Spoiler alert, you'll see later in the video. Before we get really into the video, every first and third Wednesday of the month, our FabLab offers the digital open evening from 3:30 Central Europe time. Our Discord link is in the description box as well. So, let's dive into food 3D printing, shall we? Generally, 3D printing is a manufacturing technique in which the object is created by adding layers of material, instead of taking off material as in subtractive manufacturing. Food 3D printing is the same concept, but applied to food, in particular semi-liquid and pasty foods. But to be 3D printed, the object needs to be sliced, layers must be created. To do so, there are several slicer softwares, as you can see in our 3D website, which is a very interesting site that I suggest to check. They mainly work in the same way. Here I'm using Cura. I upload my model design with a CAD software. I set the parameters and I tell the slicer software to, slice it. What I get is a preview, the number of layers and the time the print should take, but it's not always accurate. And most important, I get the G-code, which is basically a list of commands for the printer. This was the technical part, now to the fun part. A question that might arise is, why should I 3D print my food? There are several perks in food 3D printing, and here are the main two, let's say: creativity and personalization. The first one is pretty easy to understand. Just by googling 3D printed food, a wide array of beautiful 3D printed foods will pop up. There are even some shapes that cannot be achieved with traditional methods. The other one is a little bit trickier to see, but I'll try to explain. Being a smart technology, it is possible to implement a system that calculates the nutritional values a person needs and prepares the food according to those. The shape can also be personalized without the need of expensive molds or other supplies. This implicates that ingredients that are not appealing may be shaped in a beautiful way, and what are considered wastes, for example fruit pulp from juicing, can be used as a printable material. As I mentioned earlier, in general a certain texture or consistency is needed to be 3D printed. Some foods that I personally managed to print are, in this picture you can see mashed carrots, cream cheese and meat. Yes, it's turkey meat. Here marzipan, icing, and chocolate, tempered and not tempered. For these, I use some of the 3D printers for food available on the market. There are several, although not too many, and they work mainly with one of these two systems, syringe or endless screw, which I found effective, but a pain in the bum when it came to cleaning. To avoid this problem, the idea of Cook.3D was born, in collaboration with different partners that you can see now, and funded by the European Union. During the project was developed an innovative system where the extrusion is carried on in a squeezing system and two peristaltic pumps. Skipping the technicality, it means that the food is always inside, or a food-grade pouch, or a food-grade silicone tube, and so the mechanical parts of the printer never get dirty. Here are some of the foods that Cook.3D is able to print: soft cheese, homemade mayo, beer-based custard, basil sauce, hummus, store-bought mayo, jelly, pudding, chocolate compound. Here you can see the process of finding the right formulation. And yeah, now I shut up for a moment and leave you enjoy the time lapse of the printing process. Hi, I'm back. A question I get asked a lot of times is 3D printed food edible? The answer is yes. It is normal food. It is just 3D printed. Here you can see me digging this delicious sorting hat and Aztec pyramid, and they look yummy, doesn't they? And they were, by the way. So, we almost reached the end of the video. The topic is way much vaster, and there are a lot of more questions to be answered. For example, what are going to be the future developments? How is the formulation of printable ingredients? Are we going to have a Star Trek replicator at home anytime soon? And many more. But I wanted to keep the video not too long, so I remind you once again of the Digital Open Evening. Every first and third Wednesday of the month, we are there to talk about digital fabrication and answer questions, and sometimes we have special guests. Please check out our website, link is in the description box, and there you can see who we are, what we do, and how to reach us. At the moment, it's mainly only in German, but thankfully Translate exists. So, thank you very much for watching. I hope you enjoyed the video, and until the next time, bye.